What's your name?
Ejikeme Chinenwa Michelle.
Ejikeme Chinenwa Michelle. Why are you here?
I'm here to present my chemistry clock.
And that's what you're having there?
Yes.
Raise it well. Okay, that's amazing. That's great. And it's ticking.
Yes.
Okay. What is the circumference of that clock?
The circumference is 120.
120 what? What's the unit?
120 meter.
Meter? I very much doubt that. That should be 120 cm.
120 cm. Okay.
Okay. Because on an easy measure, I hope you know we can measure it now. Eh? There are how many units there? There are 60 sub-units. Yes. And here is the pair of divider, right?
Yes.
And watch it now. Let's know the circumference immediately without wasting time. How do you know? You get the distance between 2 points. Each one here, let me use. From fluorine to, this is from oxygen to fluorine, right?
Yes.
Am I pointing you well? At that line you marked, my fear of mother. It's now pointed. Now bring ruler. Sorry. So bring a ruler. Where is 1 cm?
See 1 cm.
Okay.
Yes. This is starting.
This is 1. And where is it pointing? 2.
Yes.
That's 2 now?
Yes.
So that means each unit is 2 cm. And there are 60 units. Is it that? 2 times 60.
Okay, this is 120. It's
correct. But you did not put the units well.
Yes.
So we have confirmed what you did. Never knew I would confirm those
things.
things.
I never knew that's how you check.
Yes. Okay. Raise it well. You can't just put. That's good. Now, what's the radius? Having told us the circumference.
The radius is 19.1.
19.1. 1 watt.
19.1 cm.
19.1 cm. So now, how come about this? Why did you call it chemistry clock? Because
in making this clock, if you can see, it is not normal numbers. We use elements to create the markings.
Okay. Yeah. I can see MG there. Is yes. MG general manager or management?
No. This is magnesium. This is element number 12.
Very correct.
12, 1, 2, 3, 4. You can
Why
see.
Why will hydrogen be 1 now?
Hydrogen, because it's the first element.
Why is it the first element?
Accordingly, in the periodic table, it's the first element.
Why? Why is magnesium 12?
Because according to in the clock.
What determined it? What made you give magnesium 12? What made you call hydrogen 1? Because of. Should I answer? I know you know. Reason well, though. If I answer it, you are losing mark. Why is magnesium 12? Why do you give magnesium 12? You know there are conditions where magnesium will be 24. There are conditions where carbon is 12, carbon is 6. Have you forgotten? Because the atomic number of magnesium is 12. Why is the atomic number 12? Forgot your basic chemistry. And these are the major things that constitute your clock. Why is magnesium number 12? The proton number is 12. Why is the proton number 12?
Because the atomic number
is
12.
Why is the atomic number 12?
Because the atomic number and the proton number is the same thing and they are not 12 together.
What is atomic number?
Atomic number is the...
Don't worry. You simply have to tell me because it has 12 protons in the nucleus. And that settles it. Hydrogen has 1 proton. The helium there has 2 protons. And therefore that is representing 2. Okay. You have explained it. That's why you call it chemistry clock, is that instead of normal numbering, you use the... Bring it forward. That's a You use what? You use the chemical symbols based on their atomic
numbers.
Okay, based on their atomic numbers. Okay, that's okay. Now, you have explained magnesium, helium. There are other small elements you labeled here. Present this clock now.
Yes. Okay.
Present it to an ordinary person, meaning describe the clock, tell the person how to use this clock, and say the time. To give this timing now, we after explaining it, to say the time it will read when you, because it's ticking well.
Okay. Yes, it's taking a clock.
So present
So-
this your clock.
This clock is a chemistry clock, and in making this clock, you can see clearly I used the plywood. So, first of all, before we add the engine and the arms, first of all, we have to measure. As you can see earlier, I said my circumference was 120, my diameter 38.2, and my radius 19.19.
Go straight to how it keeps time. How do you use it to check accurate time?
How is it to check accurate time? When you put the arms,
Don't worry, go on.
when you buy the clock engine, you buy the arms, you buy the hour hand, buy the minute hand, and the second hand. But you see here, we improvised, because in chemistry, you don't only use according to, you have to be creative, use your creative thinking.
I like
so
that.
after that, we put the battery. And that's what made it start ticking. And now, when you want to read the time, this says
Look at it very well,
Yes.
because we will use time and check.
this is titanium minutes to boron.
Titanium
Titanium
minutes
minutes
to boron, and to an ordinary man, what does it mean?
to an ordinary man. This is that's 37 minutes to 5.
We don't have
Look.
37 minutes to.
37 minutes after.
We don't have 37 minutes after. So it shows you people don't know how to use. What you're supposed to say is probably 4:37. Is it not what you wanted to say?
Yes.
Yeah, 4:37. Okay.
Yes.
But that's not only. Let's check if your clock is. Look at your timing well.
Yes.
But before you say titanium minutes to what? To
Boron.
boron. Why did you say titanium minutes? Because you did not explain this small thing. You are not doing well. You should explain. This is the hour hand. This should be the
Minute
minutes.
hand.
Wow, that's they say. Is that how I do teach you? Yeah, the video is on. Explain it well. You have said, now it has changed to what?
Scan.
Why is it? This is the minute hand.
Hand.
You said it. Why this one is the what?
Our hand.
The hour hand, and that's the second hand, which is very nice and improvised. Then, what is the time now? Scandium minutes to what? To boron, because the hour hand has. I'm the one doing the presentation instead of you. Now, there is something you people generally don't understand. All of you, currently you are using digital time. So let's check if this your clock is working well. It has moved from scandium to what now?
From titanium to scandium, from scandium to calcium.
Yeah, it's now calcium minutes. Why don't you read it as oxygen? Because it's for hour.
And
While
this
this
one
hand is for, okay. Calcium minutes, which means in the normal time, is calcium is number
is 440 now.
440.
440. Yes.
Yeah, 440, but there is no calcium coming in what you just said. This clock is meant to obey 1 to 30. And this time you have 440, yes, that's what it is. Let's check with this timing here. This 441 and this 441 there. It has
Yes,
shifted.
it's 441.
So your clock is working well, despite that it looks improvised. Perfect. Congratulations for that. It's not easy. But you people lack interpretation. This your clock. You are losing mark. I'm the one doing the presentation. This your clock works, but it's not your fault because you people use digital time. Do you have this clock at home? No. That's the problem. If you have it, it's just hanging there. You people don't usually look at it. It's showing here. See how this type of clock works. From, if here is 12 and here is 6, right? If the minute hand is here, you use the word after. If the minute hand moves from carbon down, from carbon to magnesium, now that's from 6 to 12, you use now to. After. to divide this into 2 equal parts. From here, that's diameter. This is after. When the minute hand is here, you use the word after. Immediately it passes carbon towards here.
Yes.
Clockwise, you use it 2. Eh?
Yes.
So, and in this case, you work in 30 minutes interval. That's why this is your clock. You calibrated it. Look at it. The first minute, this is 0 minutes. This is hydrogen minutes, which is 1.
Helium minutes, lithium minutes.
That's and you see it that way, which means now in that order until here, zinc is 30.
Yes.
So here it should be 30 minutes. You don't say 30 minutes after, you just say 30 minutes or half past. Like now it is half past, meaning it has passed half, almost half, because half of this circle here. Or if it is here, you say half past of what? Boron. It has
or
passed.
beryllium.
Or you just say beryllium zinc meaning, or you say zinc minutes, or just beryllium zinc. Then when it comes here, it becomes, you numbered it after zinc. From here, hydrogen to zinc. But here is now zinc back to hydrogen. So when you look at this hand now, watch it. It is pointing at what?
Chlorine.
Yeah, and chlorine is number what?
17.
And that's 17 minutes to 17 minutes. That's chlorine minutes to what?
Boron.
Meaning 17 minutes to 5. Are you getting it now? I don't know why people don't use this clock. You use only that digital 940. And that's 17 minutes to 5. If you want to change it to that 40 pattern you people are using, what do? You just say 60 minus 17 is 40. What?
43.
That's 443. It's the same thing. Okay. So because you saying 443, that we could have made this clock to work in 60 minutes time. You understand me now? Okay.
Understand.
Now it is not. At least you were able to say the time, but you were not able to interpret it. So how come you get these materials? How come you were able to get them? Imagine having clock engine by yourself.
Well, where I got this engine is simple. You could just go to purchase the plywood first of all. Then you go to the carpenter and explain that you want a perfect circle, like a perfect circle. He will give it to you.
Of a known diameter. You did not give diameter.
Of a known diameter.
Okay.
Then you perforate the middle. Perforate the middle so that the clock engine can be connected to the hour hand and the minute hand, which will make it to work and tick. Okay. The hour hand, minute and second hand, which will make it to work and tick. Okay. Originally, the engine, it comes with the second hand. Okay. It's the hour hand and the minute hand that you have to go and purchase in the market. Okay. Then you buy your batteries. Okay. You buy your battery.
Then turn back the clock, and that's a good job. Where is the hanger? What would we use to hang this clock? You don't have it.
It's not yet inserted yet.
Crazy where there is no hanger, it loses mark. You can't hang it. How do you now keep it? Yeah. So, but congratulations, AGK. It's not easy. We will keep this in our school. I promise I will modify it for you. I will improve on it. At least it's the largest of the whole clock presented by your set. As in the size is very large and bold, very smooth. So congratulations. Thank you. How did you find the thing? Is it challenging? Was it?
No, it was
when
easy.
You were told to do it, how did you feel?
When I was told to do it, I thought it was impossible because I didn't know where to start getting clock engine, because nobody has ever given me a project in this life where you will make something and make it to work.
Okay,
so it's
only by drawing. Oh my God.
Or draw or make or construct, never working.
Okay,
so
those things
when
are
I saw
models mimicking the original, but you have made the clocks
original.
by yourself, keeping it. So that's science for you. So nothing. Next time you try in your life making the clock engine, do you think it's impossible? It is not impossible. Since you have done this, you can equally start from scratch and do it in future. That's the reason for this project.
Yes,
so
that's how she come and do it.
Okay. What's your name? I can't hear you.
Onyemechi Favor.
Onyemechi Favor, why are you here?
I'm here because of my project, the chemistry club.
Oh, chemistry club. Can clock be actually chemistry?
Yes.
Okay, what's the concept? Where's the clock? Show to the camera.
The clock.
Let's see. Okay. That's wonderful. Okay. It's a chemistry clock. Why did you say it's chemistry clock?
It's a chemistry club because numbers have been changed to the different elements in chemistry.
Oh, instead of the number.
Yes.
I can't see what it is. Okay. That's why MG, what does it mean?
MG is 12.
And it stands for?
Magnesium.
Why should magnesium be 12?
Because that's the normal proton number.
Oh, so it is numbered according to the proton number.
Yes.
Okay. That's correct. Then what's the circumference of the circle? What's the circumference of this your clock?
It was actually confusing, but I took my time and the circumference was finally 19.2.
What's the unit? 19.2 what?
Centimeter.
I doubt that. 19.2 all round this.
Okay, individually.
No, circumference. You failed that question. Remember when I will mark you? That's if you can bring a thread, what will go around this? I'm very sure it's more than 19.
If I can bring
So what's the? If you don't know the circumference, it's obvious you don't know the radius. What's the radius? Now turn it around. What do we use for hanging the clock? Okay, that's the hanger. Now turn it around. It's not. Your clock is ticking. Tell us the time.
The time is nitrogen minutes past helium.
Turn it around. Nitrogen.
Minutes past helium.
Nitrogen minutes past helium. Okay. And the nitrogen minutes past helium, but okay, it has changed to oxygen minutes. Look, it's pointing at oxygen minutes past helium. Okay, the bigger ones are the hour hands, the smaller one are minute hand. So let me check. Here is still nitrogen, is a minute faster. This is still nitrogen minute. Don't worry, it's okay. A minute faster is not a big error. And to an ordinary man, nitrogen minutes too means what?
To an ordinary man.
After, to normal clock timing.
207.
Okay. 207 is not telling us after or 2.
Okay, 7 minutes after 2.
Fine, that's great. Now present this clock to a novice. Interpret all these your writings, what it means. We face the camera as you explain.
Okay, if I should have the opportunity to present.
That's the opportunity.
Yes, the opportunity has been given to me to present this clock to a novice. First, I would like to tell the novice the steps before I begin to explain how the clock can be used. First, you have to use a plywood, but this is not a plywood. This is much more thicker than plywood. So you have to go to the carpenter because as a novice and also as a student, you might not be able to have the material for cutting the circle. So when you go to the carpenter, maybe before calculating ahead, so you will get 1 cm to each, you can tell the carpenter the diameter you want for your chemistry clock. So it's now the carpenter job. When he's done cutting it out, if you feel you don't have the material at home to puncture the middle, then you can calculate it as the carpenter is still there and then give him an opportunity to puncture the middle. So after doing all this, then I went home and then began to calculate. First, you have to find the diameter and then get the radius. After getting the radius, then you can now get the circumference. After getting the circumference of the circle, then you have to divide it by 60 because this is a clock. So a clock is mostly 60 minutes 60 seconds, so you have to divide it by 60 in order to know the minutes and the seconds. So after dividing it by 60, then you now begin to calibrate. So I calibrated it with a compass, and I also used an artist knife. So that's why, okay, I also decided to polish the wood. So while using an artist knife, you can see that it cannot be cleaned. This cannot be cleaned. So I used a compass and an artist knife, and then I began to calibrate it. So it took me a long time because I was trying to be careful, and I also used a marker to indicate the points for the calibration.
Okay, now what you just did is the process. Now present it for easy usage. What does this thing mean? Because I can see oxygen twice, like over here is oxygen, and coming over here I'm still seeing oxygen. So what does it mean? Those letters you used, you have told us, we don't know how come you are using MgH, You try to let.
So, okay, according to chemistry, this is magnesium, which means 12 because the proton number is 12. So magnesium, hydrogen, helium, lithium. So if we should go around it, we'll see that it's 12. 1, 2, 3, 4 till that same 12. So, and then the second times also goes round 60 times, so indicating it always goes a minute. And then we decided to make first 30 elements, and first 30 elements. When it's at this side, it means after. Like you can say sodium minutes after, and when it's at this sodium, it means sodium minutes too.
Okay.
So this is 11 minutes after and 11 minutes too. So you have to be able to know the numbers. And this also, first 30 elements, we stopped at zinc, copper, nickel. So it also goes like that, hydrogen to this. So but according to a novice, the elements has to be written down with their various numbers for you to be able to accurately get the numbers, so we can see it.
So let's check the accuracy of the clock. So what's the time now?
The time
viewers
is
are seeing the time on the screen. Don't look at right. Okay, look at the time here. So
I set the time according to my watch.
Fine. So
the time is magnesium minutes after helium.
Okay, magnesium minutes after helium. That should be 12 minutes after
2 according to my watch.
So it's still 1 minute ahead of the normal timing. No problem. That's a great work. Favor, you really tried. You did a nice job there. So, but how are you feeling? Was this project an easy one?
No, I did not sleep for 3 days. It was really stressful. My mom started complaining. She wanted to meet the teacher. She was because she said that irrespective of the fact that I have senior brothers that have gone past my stage, that none has ever given her a stressful project. But I'm thanking my mom. She actually supported me. She was encouraging me on, and she was following me to the carpenter at any point I needed a problem.
Okay, so now the question is, would carpenter have done this without your directives? Because this should be your project and not that of the carpenters. You're supposed to do this 100%. How come the engine, the ticking hands, did you buy clock and break it and break the hands and the engine behind? So
no, as we can see that I was one giving the carpenter a choice. The carpenter was acting so stupid that he did not understand what chemistry clock was, and he told me that
you shouldn't be stupid at all. He said he don't know it. He don't know it. You are the one. That's not stupidity. Points of correction.
And then he told me that it's not proper for the teacher to give me this project as if I'm his SS1, because he looked at me as if I was a university student, because he said the project was too much for an SS1 student, but he could see that I knew what I was doing because I was directing him. And at some certain point when he tried to argue with me, I always told him that I was in charge and it was my project. Okay, so the engine was not too expensive. It was 2,500. So when we bought the engine came with these hands, and then before the engine has to be fixed, you can see that this place is brighter. It shows that a mistake was made by the carpenter. So I had to go back to the carpenter, and the engine was pulled out and this place was closed. The closing of the hole was my work. I had to use a super glue and I used a small wood to close it. And then I went back to the carpenter to finally, I stayed awake all night finding the middle of the circle, and I was able to find the middle of the circle.
Then how were you able to find the center of the circle? You should read what center either. Okay, that is why we're now. You told us you found the circumference or this. But unfortunately, you couldn't tell me the circumference. Well, that was the first question I asked you.
Exactly, I couldn't tell you the circumference because I've really forgotten. Now I just wanted it to be prepared. I've really forgotten, but if you have an opportunity
So
to
the
use
calibrations, what makes it accurate? So you didn't tell us in details how you're able to divide so that it's pointing and it remained. It was like currently it's still pointing at that's phosphorus. That should be 15 exactly. You see, so how come it's accurately calibrated and it's possible that it will be pointing at phosphorus and unfortunately it should be reading 15. Now it's leaving 15 going towards sulfur, which should be, so the calibrations were accurate, which means you have done some mathematics here.
Yes, it was a very stressful mathematics because the first time I did it was a mistake. But as I was able to get the circumference, I told you I divided it by 6 and I got 1 centimeter. So this calibration, I was able to use 1 centimeter with a ruler, and then I got a compass and placed it on a ruler to make sure it was 1 centimeter.
So 1 unit, a minute is represented by 1 cm.
Yes.
And that means you should know your circumference. Since we have 60 minutes and a minute is 1 cm, the circumference is 60 cm.
Yes. Thank you.
So,
circumference is 60 cm.
Such that you can also find the radius.
Yes.
Thank you. It's a nice job. Congratulations. At least you are bright to the camera, presenting well. But I'm not going to give you 10 over 15. 10 over 15 because you write, it's 10 over 10 for this. Then the project write-up is 5 marks. Okay. So what do you score yourself inside 10?
9, because I was not able to say the circumference of the work I did.
You didn't tell me also the diameter. Neither did you tell me the radius.
No.
And Sarah, calm down. And the carpenter was involved to an extent. You could have made this cut by yourself. If you say you don't have the equipment, I will pardon you. The implement.
And this
should be 100%
this is
centered
not fully
on you.
plywood, so it would have been very difficult for me.
It's supposed to be student-centered, 100%. The carpenter, what you could have said, you borrowed from the carpenter and do the cutting. But I got your excuse. Okay, the thickness is too hard for you to cut accurately. But what matters is that if you are not involved, I'm very sure this won't be keeping time. But because it's keeping time, I think you deserve 8 over 10. How about that? Your project, if you write all these things, you tell us now in a summary, your challenges, how you're able to succeed. And then, how do you feel with yourself now?
Wow.
Why? Because I gave you 8.
Yes.
Fine. Apart from the score, how do you see what you're able to do in chemistry?
I feel very happy.
Do you know you can make your own clock before now?
No, I was part of the people saying that I do not want to go for midterm because of the project.
Okay. Now, you see it can be done.
Yes.
So that's just by the way. What's the aim of this clock? To teach students the first 30 elements using chemistry. The clock is there teaching you first 30 elements. So it's advisable if we can modify this and every home should have it. It sounds funny. Say, like now, what's the time again? This should be...
The time is Argon minutes past helium.
And to ordinary man, how many minutes? Say it's the normal time. In Argon minutes past helium means
80 minutes past 2.
Very correct. So it's very accurate. Your clock is very accurate because it's keep varying with that 1 minute ahead because what you use to set it is your own watch. Congratulations. Maybe I should make it 9.
Yes, Uncle, please, because it's accurate.
Yes, that's one reason. So maybe my office will have that, and every home we can modify this. Sponsors are needed. Thank you. What's your name?
Chidi Messi.
Chidi Messi. Class?
SS1Y.
SS1Y. Why are you here?
Here to submit my project.
Wow, what's that project?
Chemistry clock.
Chemistry clock. Can I see? Wow, it's amazing. Ha. Looks beautiful. Congratulations. Take it up again for camera to see what. You call this thing what?
Chemistry clock.
And there is even, is that glass? I told you not to use fragile thing. What do you use that?
It's plastic glass.
Okay, that's plastic glass. Very correct. Very perfect. Okay. What's the circumference of this clock?
Circumference. Okay, the area is
You don't know the circumference. Fine. Now, what's the time now?
2:50.
Okay. Unfortunately, that doesn't make a chemistry clock.
I mean, helium, neon.
Unfortunately, you are using minute time for hour time. What I have here, exactly from your calibration, should be oxygen. What you calibrated, though, of which I know is faulty, oxygen minutes to lithium. And that automatically means, to a layman understanding, 8 minutes to 3. So explain this clock to a layman. Why did you write magnesium, all these symbols, instead of writing 1, 2, 3?
Because it's a chemistry clock, and a chemistry clock you have to use.
And what does it represent? Explain to an ordinary man how to use this to learn chemistry, relating it with the normal timing we know.
First, you have to know the elements and their proton numbers.
Fine. Give us. Explain them with relation with the project you are holding, Mercy. This is the major presentation. Your work is nice. You didn't tell me the circumference, and that led to the faulty calibration. You know, I will not accept this calibration. See why? Just raise that clock again. Do you see the distance between magnesium and hydrogen, then sodium and magnesium? It is obvious that the hour time will never point those ones correctly. When it is going to be hydrogen o'clock, it will be pointing at the lithium minutes hand. Like, it cannot point directly to that hour. The same thing is applicable when we talk about sodium. That's about 11. So why did you write magnesium here? Magnesium represents what hour?
The 12 hour.
12. Hydrogen represents
1,
helium,
2,
lithium,
3,
carbon.
6.
How come there is zinc below that carbon? What does it mean?
That's the 30th minute.
Fine, that's the 30th minute hand. Why should zinc represent the 30th minute?
Because zinc, its proton number is 30.
Very correct. So, what is the aim of this clock?
For us to know our elements very well, to know the time using our elements.
Okay, trying to match time check with the first how many elements?
First 30 elements.
First 30 elements. Okay. What's the time for the second time? I have my own timing here. Look at my timing. So, what's your own now? Definitely it's going to be wrong because your calibration was wrong. But say exactly according to your calibration.
Helium 50. Helium carbon.
Helium carbon. You are mixing it up. Oh, Chidi, Mercy. You don't know. There is no more. That's beryllium minutes to lithium. You don't even know the minute and the hour hand. Is this one not the minute hand?
Yes.
This is the hour hand. And whatever this is pointing at is this one behind now. While this one is pointing at the bold letters. So this is pointing at beryllium. That's 4 minutes to lithium. That's 4 minutes to 3. According to your calibration. But unfortunately, what do we have here? We have 7 minutes to 3. Because you did not calibrate your minute hand well. You don't know the circumference. Fine. That's why you will not know. You didn't divide well. And at least this was typed and not handwritten, and that made it look nice. But you are the one that will tell who is typing and who is printing the circumference. See where the error is, Jade?
Like when I did it in my book, it was correct. But when I give a person to do it, the person now.
Fine, that is your. You are back here now on the second chance. So let's see your clock. You have corrected it, right? See, yeah, this calibration looks very perfect now. So,
149.
and that 149 is supposed to be what? Sodium minus 2. Is it pointing to sodium?
No, magnesium.
Okay, so it's just 1 minute. No, it depends on your own clock. Let me check my own. Sodium minutes, okay. That's very correct. Your own is not correct this time. This one, your clock is correct. It's pointing magnesium, which is 12 minutes now. And this is 148. And 148 means 12 minutes. So what are the challenges?
Number one, the calibration. That's
Very correct. You calibrated wrongly first, which was rejected, and it was typed. It was beautiful, but was not keeping to the angle according to the hands. How were you able to get all this material? Did you buy clock and break it?
No.
So what did you do from scratch? You explain the parts.
I bought the plywood. Yes, and the clock engine, the clock hands, and also a black tape and plastic glass.
Plastic glass, but there is this.
And metal.
Okay, here is a metal. Okay.